This video, we will do a fourth example for setting up the triple integral given a 3D shape. So we have a 3D shape right here. It says that this shape is the wedge cut from the cylinder x squared plus y squared equals 1 by the planes z equals negative y and z equals 0. So let's begin by setting up this triple integral. For this problem, we could do dz first, dy dx, or we could do dz dx dy, it does not matter. Now it already says here that z is equal to negative y. So that means that our upper boundary will be negative y and our lower boundary will be 0. Next thing you want to do is you want to find dy dx, and to do that you want to graph a 2D shape using this formula. So if you graph this, you have a circle with a center at 0, 0 and the radius of 1. So you want to find dy, therefore you want to solve for y. So y squared equals negative x squared plus 1. Find the square root of that. Y equals square root of negative x squared plus 1. However, we can't have a negative inside a square root, so we have to take the negative out. So you have x squared minus 1, because if you distribute, it will be the same thing. Okay? Now, we know that this shape right here, it does not include a positive y. And if this is the x-axis and this is the y-axis, it would not include this part right here. Therefore, we're working with only this bottom half of the circle. And if the bottom of the circle is negative square root of x squared minus 1, the top of the circle would be here, and this point is at 0, 0. Therefore, the upper boundary for dy will be 0, because say if you have a slider that goes from left and right, so if this slider is like this and you want to slide up and down, you can only go up until this point, which is 0. Now to find dx, we're going to imagine we have a slider that goes like this and it slides left to right. You can slide left until this point right here, which is negative 1, and slide right until this point right here, which is 1. Therefore, the upper boundary will be 1 and the lower boundary will be negative 1. Now this will be your triple integral for this shape.